working with this, it's going to be the same but a little bit different. Something else has been added to it. So previously, when we coded in some of the animation or the modification to create the animation using speed x and speed y, we wrote it as x is equal to speed x, or x is equal to x plus speed x. Now, the line above here where it says x plus equals speed x is a shorthand notation for x is equal to x plus speed x. It's a very common programmer convention to do it as plus equals versus writing it out in the more verbose style of x is equal to x plus speed x. So moving forward, you are going to see that we use plus equals regularly in the code that we write, because that is how you would more traditionally encounter code when you find other people's reference. So you need to understand that, and it's an easier way of writing it. You will also see when we multiply by -1 that it doesn't work just for addition, but this line is the same as speed x times -1. So again, it's shorthand versions of writing it. So times equals plus equals are simply the shorthand way of writing that statement. So I will be using in the examples moving forward plus equals, minus equals, times equals, or divide equals in lieu of writing it out in its full verbose manner. So I will be going forward with that. So if you see that, don't freak out and go, wait, I haven't seen that before. Now you've been told. Now it should become easy. Over time, a lot of these things, it's just like learning a foreign language. Once you grow accustomed to it, you accept that convention of doing so. Code more efficient, though in the beginning, you will look at it and go, well, then that's more stuff I had to write. But what it does is it helps us to organize the code. And if we can organize our code to make it more efficient, then as our programs grow more complex, we're going to be able to handle that complexity, because then you won't have to keep reading through line by line by line over and over again to mentally try to understand what is occurring. So when I look at what's happening inside my draw function, so remembering that up or setup and draw are simply, these are functions. These are actions, collections of things that I want my program to do. So setup is the collection of things that are all about getting my program ready to run. Draw is the function that is going to execute 60 times per second. Now, it's doing a number of different things here. One thing it's doing is it's clearing the background. Another thing that it's doing is it is updating the x and y position of my object. Another thing that it's doing is it's checking for collisions with the boundaries. And finally, it is then rendering or drawing my object to the screen. So each one of these tasks in and of itself is a separate activity. A general rule of thumb when writing code is that a function should really just do one thing. 1, 2, 3, 4 things are happening inside of this function. So what works better is to separate those 4 things out into their own functions, and then our draw function is just going to then call each of those activities. And in the process of doing this, it's going to make our code significantly more readable, and that will be really important when we start adding to what our program does. So to that end, the first thing that it's doing is it's clearing the background. So I am going to make a function, and I will call it clear background. Now the names of functions can be whatever you want them to be. There are no rules on what you would name a function, but general convention is function names start with a lowercase letter. If you put multiple words together to describe what that function is doing, we use camel casing to separate those words, because if that is lowercase, it's much harder to read clear background. But if each word of that name is capitalized. Now your function names can be almost whole sentences, so you can string together as many words as you want. The names you use for your functions ideally should be reflective of the activity or process that they are doing. It shouldn't just be short for the sake of being short. It shouldn't be random. It should be reflective of what do you want to happen with that. So the first thing that's happening is we're clearing the background. The next activity that we're doing is we are updating our position. So I will now create another function, and we'll title this update position. So these functions are not returning a value. So I'm not passing something into them and they're giving me something back, but they are just functions for executing a set of actions. And because they don't need to give me something back when it's done, we preface the function with the word void. It's possible to have functions that give us something back. They may return a number. They may return a Boolean value, true or false. They may return a string. So they will take input and give us back words. So all of those are valid actions for functions, and then those functions are returning a value. But when our functions don't give us back anything, we preface it with the word void. Now the third activity was we are checking the boundaries. Okay, why is it? Figure out why it was freaking out and I forgot to put my parentheses in when I was defining my function. So inside these parentheses, if our function takes input, so we pass something to it so it can use that as part of it, which we will be doing later today, then it goes inside those parentheses. So we clear the background, we update the position, we check our boundaries, and finally, our fourth activity that is happening here is we are displaying our object on screen. So I have 4 functions here. Now, one thing about working in processing is the order that we list the functions in our code does not matter as long as setup happens first. After that, we can order the functions in any order we want because it's going to read through all of the functions and then start executing the code in whichever function is being called to happen first. So setup could be calling a function because you may have inside of setup you call a function to initialize all the objects in your game. So you would call that, or you would have a function to reset game parameters or game values. So if you have a game where you have health, you have score, you have enemies, positions, and you need to reset that to replay a game, you could have a reset function and you call that. But the order that we see them happening inside our code isn't determine that it doesn't execute them in that order. We just have all of the functions and now they're accessible, so then our program can call whichever function it needs. So if I look at setup, these lines happen in that order. Setup happens first. After that, it's going to go into draw and do whatever draw asks to run next. Now my setup, if it called a function, would happen before draw would ever execute. So that's part of the kind of the order of operation that happens here. Now, to finish organizing this, I need to move the respective sections of code to their function. So I will grab the code that clears the background and put that inside of clear background. I'll grab the code that updates my position, put that into it. Grab the code for checking my boundaries. Put that in, and finally grab the code for drawing my object. Paste that in. Now if I run my program, absolutely nothing should happen, because my draw function has no code in it. So the final step in this conversion process, now that I've moved the code into each one of my functions, is I need to then call those functions. So I call clear background. Then I call update position. Then I will call check boundaries. And finally, I will call display box. And now when I run the code, I see it looks exactly the same as it looked before. But now when I look at the actual code I have, it's significantly more legible and human readable, and the order in which things are happening, how it's happening, makes more sense because I can look at each function that's being called in the order that it's being called, then find that function and see what that function is doing. So you could put lots of comments into your code. So your draw function could be like 200, 500 lines long. But if you did that and tried to then figure out how your code is organized and structured and what is happening, if you didn't have good comments, it would be a nightmare. This way, it allows it to be much more organized, which is going to be useful as we move forward and start adding in more items to our programs. To take this and prepare us to go one step further, if I wanted to have 2 objects or 3 objects or 4 or 5 or 100 objects, I could do that. I'm going to just make my point using 1 object, or I mean 3 objects. Oh wait, that should have been 2s. So if we have relatively identical objects, it becomes an issue of figuring out where and how to put them on screen. So let's, this one be minus minus, and this one will be our slow box. So each one of these objects, it's going to, we'll make them different sizes, different speeds, even different colors. But what we're going to find is this is not going to be a great way of coding, because as we do this, it's very, very, very inefficient. So I have 3 boxes that I'm making. One gets the X, so no number, then the other one has 2, other one has 3 as part of it. Clear background, that won't need to change. Update position. Now this, with 3 objects, again, this is manageable. Now, if my objects are really complex, it's going to be kind of sucky. Checking boundaries is going to be a little bit sucky here, because I'm going to come back to that one in a moment because I just don't feel like dealing with that one yet. So with having the multiple objects all okay, objects, because I changed their sizes, may fall apart a little bit, but that's all right. We'll live with that for now. This further should illustrate one of those situations where when we have code that is pretty much duplicative, so it's for the identical objects, but is not, it just changes 2 parameters, but otherwise the objects behave the same. This is not a good way to go about coding like this. So if we run it right now, we'll see we get 2 of the objects are going to run off screen, only 1 stays because we've only done the 1 boundary check. So this is just a really bad way to go about doing coding. That's also why I called this particular sketch bad on it. Now, let's see. So they're all bouncing around. Oh. Some got wonked on. Oh, forget some. And this is also why if we forget values, 2, 2, 2, 2. Now I think that. All right. So now I think it's fixed. So 3 objects, our code got 3 times longer. But if I wanted to go up to 5 objects, 100 objects, 1,000 objects, this would not be a way that we could do. This isn't a sustainable way of working. Could you do it? Yes. Do you want to do it that way? Absolutely not. That's really bad programming. That's a bad approach to use. So we don't want to go this way. So we don't scale it up by just adding in more and more x, x2, x3, x4. That's just bad. We don't want to go that way. Of programming, we have something called object-oriented programming. To turn our code into an object, which will greatly benefit us when we want to move beyond 2, 3, 4, 5 copies of the same thing, but now to have an unlimited number of copies, but also to have more organized and effective code, we need to introduce a class. So to do that, we could add what we are doing to the end of this file. We could just write the word class and add it in. But it's easier if the class is stored as a separate file, because then it helps us to have our documents a little bit more organized. So to do that, what we can do is we can select New Tab. And when we do that, it opens up a new tab. Now it says new name for file. So it's prompting us here. A convention when we are doing class-based programming is that the name of the class object is capitalized. So by convention, we capitalize that name. So I am going to capitalize the word box. Then I'll hit OK. It's now created that file. If I look in my folder, my project folder, I will now see that there are indeed 2 files there. Notice box is capitalized. The syntax when we are creating a class. We start out with the word class. Then we put the name of this class. In this case, the name of the class should match the name of the file that it's in. Then I put a curly brace. I'll hit return twice, closing curly brace. That's the starting point for my class. You'll notice that unlike a function, there are no parentheses there in front of that curly brace. So I don't say void box parenthesis close parenthesis then curly brace. It's just class, class name, curly braces. Now inside of a class, we will define our properties. We are going to define our constructor. And finally, we will define the methods. The methods are what our object, our class object, knows how to do. The constructor is where we initialize its starting properties and values. Properties are where we list the different things that our box needs to have as part of its existence, as part of its identity. If I go back to my objects file, I will see that we have some properties here. Those properties were initialized. And then we have some methods that our object is probably going to know how to do. So to that end, we're going to put our properties in. We'll put in a constructor, and then we will define out the methods that go into it. So the first thing is I am going to grab. So I'm going to, when I'm taking the elements from my main file, right now I'm not going to delete them just yet. I'm just going to copy and then comment it out. And then I will go over into my box and I will paste in those properties. So our box is going to have an x, a y, a width, a height, speed x, and speed y. And it's also going to need another value. And it will be color. So I will do it as color C because I want each one of my boxes that I create to be able to have a unique color associated with it. Now the box constructor follows this syntax. I put the name of the class, throw in some parentheses, curly brace, twice, close curly brace. If I look at my class file right now, I will see the file name, the class name, and the class constructor function all are the same word. Capitalization matters. So when coding, capitalization is generally going to be something that always does matter. White space, extra returns, spaces, things like that varies, but capitalization almost always is going to matter. If I go back now into my file here, I will see that I have properties, so I'm going to copy those and comment them out. Go back over to box. I'm going to paste those values in, and I can move them over, so I can move the indent over. The keyboard shortcut for moving indents left or right is Command and then square bracket. We can also see that under Edit, increase indent or decrease indent, so you can see there's the keyboard shortcut for it. I could have also hit Command T to auto format, and then that would have cleaned up the whole item as well. So that would have been something else I could do. So this now defines out the properties, everything except the color. Now for the color, I am going to set my color equal to a color value. Looking in the reference on processing, we can see that colors are defined using a number of different methods. We can define them. Easiest is we're typically going to be using RGB values or RGBA values, depending on how you want to do it. And we can see it's done with the color word, and then we put in a red, a green, and a blue value. If we are adding in a alpha value, we put that in as well, so it's RGBA. If we want, we can change our color modes. We could change it to HSB. We can also work with hex values, but it's harder to do conversion between hex values and RGB values because RGBs are just straight numbers. Hex are the letter number combos, so that gets a little bit trickier. So my recommendation is just stick with using RGB values when you are defining out your colors. Back to the code, we will say color, and now I can define out what my color value is going to be. And to that I could just say 255, 0, 0, and I will have, it's a red box. But if I don't want my objects to be all red, because now if I made 3, 5, or 100 objects, they're all going to be red. We do have another option where we can define our color values using random. So I am going to assign random RGB values between 0 and 255. So now each time I make a box, it's going to be some weird random color. I don't know what it will be, but it's going to be its own random color when I make a box. If I don't want it to be truly random, if I want my colors to be within a range, I could do it a reduced random amount and then add to that a certain amount, so then that would give me within a range. So if I wanted it to be between 100 and 150, I would do random 50 plus 100, and that would give me a range between 100 and 150. So we could use different values as part of it, but now this sets up my object, so it gives me those random values. So I'm going to, each time I make a box, it will have a unique new color. So we have set up the properties, we've set up the constructor. Now what we need to set up for the box is it needs to have update, check boundaries, and display worked into it. So I am going to copy this, comment that out, because we won't be using them anymore in our main function. And then those methods are going to work their way into my class. So now I have update position, check boundaries, and display box. I'm going to change the wording on these just a little bit because I prefer to just keep it a little bit shorter. So I have update and display as the two methods. Check boundaries, you could shorten to check bounds, especially if you find you misspell boundaries, because that's a lot of letters in one word, and it's pretty common to your fingers give up partway through and you just call check bounds. So that's a little bit easier to work with. So I've modified the method names to update, check bounds, and display. Something also to keep in mind is if we think about this, it makes sense that we are updating our object, its position information. Then we check to make sure it hasn't gone off screen. If so, we prepare to try and make sure it stays on screen. And then finally, once we've taken care of all of that, then we display the object or draw the object to the screen. So now our class object is done. I'm going to just hit save, make sure I don't lose anything. Now, if I look at my main program here, it's kind of freaking out a little bit because it's like, hey, where's update position? I don't see it. I don't know what's going on. So we're going to work with that. Now, the way that we're able to add one of these boxes to our program is I can simply, it's an object. And as an object, we will then use a variable to hold a reference to it so we can know that it's there. Well, a float is a number. In this case, our object is a box, so I will reference the box class. And I'm going to just call this B1 right here and put that in. Oh, I need my semicolon. Then I can say in my setup, B1 is equal to a new box. So what this does is this says B1 is going to be an instance. You could kind of say a copy of the box class. Now, to get it to work inside our program, I'll just comment those out because they're not working. Now we say B1 update, B1 check bounds, and B1 display. If I run it, it works. To finish the cleanup in the code, I'm going to get rid of what was there, but just to walk through it one more time. So we had our properties for a given object. Now those are encapsulated inside the class, so we don't define them directly in our main program. So what we're going to be finding is our main program is going to become much cleaner, and the logic, the same way that we organized it into functions, by organizing logic for an object into a class, allows us to separate out that functionality, cleaning up what we're doing. So now my main program is pretty short. Under my objects, we can see that, or variables, I have my B1 box, create a new box, and then every frame we're just going to tell that box to update, check its bounds, and display itself. To add to this, I could say box B2 B2 is equal to new box. And then B2 is going to update, check bounds, and display. Now if I run my program, I will notice something that I only see one box. So that tells me we need to do some modifications here. And we have two options. One is we can tell our boxes to just randomly spawn themselves on screen. The other is we could pass in a value of where we want them to show up. We could even pass in what color we want them to be. But I'm going to notice something else happening. Inside my box, I created a color variable, but I never used it. So if I want to use that value, instead of filling with this color information, I just fill with C, because C is my variable of color and it's a random color. So I now fill with C. Now if we run it, we can see, ooh, we have mauve. Run it again. Olive drab. Dark brown. Teal. Blue. So each time it's coming out with a new color. But our boxes are all spawning at the same location, same size, and same speed. So if we want our boxes to be different, we could throw some more randomness in so that they appear in random places. Right now I'm going to give the boxes random speeds. But we're going to, when we construct the box, we're going to pass in some values. So when we construct it, we're going to say, hey, I want it to be at this specific location when it starts out. So we're going to look at that in a moment. But first, we will just do random speeds. So we'll just do random 3 plus 2. So this gives me a random x speed anywhere between 2 and 5. There's a random number of 0 to 3 plus 2. So, because if I just said random 5, then we'd have somewhere they have no x velocity to speak of, and that would just be ugly looking. It also means they're not going to be moving necessarily equal speed x and speed y because they both have randoms put onto them. And now you can see they are indeed moving different, and each one is a different color. To make each box start or appear in a random location, what we can do is we can pass in values. So I can now pass a value in when I go to create this object. So I could pass in a number. So I could say like 100, 300, and 700, 300. So they're in different locations. Now, if I look at the error message that's coming up at the bottom, I will see in the error message it says the constructor box int does not exist. If I go into box, I will see box doesn't say int, float, or anything. It just says box, and that's why it's giving me that error message. Now it thinks I'm passing in an integer because I said 700. If I said .0, .0, now it's going to say box float does not exist. Now an integer is a float, but a float is not an integer because 100.0 is the same as 100 as far as floats are concerned, so you don't have to add in that if you're using the whole number. But here, x and y, the values I'm passing in, are indeed floats. So I would have to say float Now it's giving me a warning. It says the value of the parameter start x is not used, and if I did something else, it'd say, and same thing for start y. There's a couple of different ways that we can. Now I'm calling it start x. Sometimes you will see in some references where it would instead say like underscore y, or x, sorry, x here, and I would go underscore x. So you can see the connection here of I pass in a value and I'm assigning the value of that object to that. So some conventions of coding like to use the underscore notation so that you know it's the same, you're using it for the same purpose. Others like to use a different name and assign that name to it. Both are valid, and you can decide what method works best with your brain. I bounce around and use both, kind of depending on my mood or what other kind of coding or programming I'm doing at the time influences which method I would use. So right now I don't have consistency, which makes my code ugly. Sometimes when you see with underscore, but it's the same thing, it's confusing because then you're like, wait, which is which? On the other hand, you know that when you see this, it corresponds to the name of the internal property of that class object. So then that has that consistency. So it's kind of both work. Now if I run it, we don't see any change in value. But the advantage of what I've done here is I've now been able to say, when I create this object, where I want it to begin. And if I just, for whatever reason, so if I wanted it to begin on screen, if I say 800, that puts it somewhere on screen. But I might not want the full value of it. I might want it to be somewhere else. When we do random, we don't have any control over where it appears unless we narrow down that range. So if I did random 600, but then added 100 onto it, that means my values would be between 100 and 700, putting the box on screen but a little bit away from whatever margin, so it's never going to appear right at the edge of the screen. So we could narrow it down, or we could make it a smaller value. So 600 plus 100, that gives me a total range of 700 out of 800, so that's going to be within 50 pixels of the margin. That's what that tells me. If I wanted to be further away from the margin, I could adjust my math accordingly. More thing in, and I went back to our original constructor and recreated the original constructor minus, the randomness, of course, and speed. And the original constructor had no parameters going into it. Our other constructor took 2 floats. Now if I look at my code here, I'm just going to get rid of those because it doesn't really need it, it'll work. So these two are working with the constructor that accepts an x and y parameter. This box doesn't pass in a parameter, and we have a constructor ready to accept that. So 2 ways of constructing it. So the box class has, as written now, has 2 different construction options available to it. Now this is something that may be kind of esoteric, theoretical knowledge that you don't have any direct application for, but there are times when you do more advanced projects where you will want to have variations of the same thing without making class 1 and class 2 that are 99% identical. Anytime you have code where it's super duplicative and repetitive, that tells you that there's got to be a better way to do it. Because the goal when we're coding is to not repeat our code. Because I don't want to make one box class that defines box with values and one box class that would not use those values. That would be silly when the rest of their methods are all the same. So if, in this case, we can have different constructors. Because I know within the language there are functions that do take different constructors, and we can see that in the reference here. So the color is an option because color takes a straight value. If you just fill it with, say, 128, then your color is just gray, and it tells you it's a grayscale color. If you use 3 values, it tells you it's an RGB value. If you use 4, it's an RGBA value. So the color class, because this object here, when I say C is equal to color, what I'm actually referencing is the color class, which has these different methods of constructors built into it. That's why it's able to take all of these different kinds of values as part of it. So that's an internal class that is built into the language. So that's why we can do this. So now I have 3 objects. And even just using this class method here and working on it like this, I could go up to 4 objects, 5 objects, 10. That would be really annoying, but I could. But if I wanted to do 100 or 1,000 boxes on screen, that would be bad. That would be hard to pull off. So now we need to find out a better way. Loops are a way that we can get code to execute regularly and repeatedly and make stuff happen with it. Currently, I drew a line on screen. It goes from 1010 to 10 410. So it gives us this vertical line. If I wanted this line to repeat as a series of lines that are going across my screen, I could write it out here. Now go plus 10, plus 10. Now if I run it, I should have 2 lines. Plus 20, plus 20. So you can see 3 lines. And this is going to be a really tedious way of going about doing this. And again, programming is one of those, anytime your code is repeating with any version of a pattern to it, it usually becomes very apparent that there should be a better way to go about doing this. So if I want to repeat this, what I can do is I can use what is called a loop. And we have a couple of different loop structures available to us when we are working with coding. So instead of repeating the same lines of code over and over, incrementing these numbers ever so slightly, what we're doing is we're drawing a series of lines where we're really looking at x plus equals 10. So the difference on these lines is x went up by 10. X was at 10, then we added 10 more, 10 more, 10 more. So each time the difference that we're looking at is x has increased by 10. To continue with that, what I could say is while, and the way a while loops is, this is, now I'm actually writing in English here. I'm going to write it out, which is while a condition is true, a condition is true, do something. That is how a while loop works. So the way that we do it is we set it up, and just comment that out because that's just the language of what we're looking for. We say while, and then inside our while loop we say what that condition is, and I say, well, x is less than, I could type in 800, that's the size of my sketch, but I can also type in width, which is the size of the sketch as it was defined inside of setup. So while that condition is true, then I want to do something. And while that condition is true, then I am going to draw my line x comma y comma x comma y plus 400. And then I will say x plus equals 10. So now what's going to happen when I run this is it's going to start out with x at 10. That x 10 is less than the width, so it's going to run this. Then it checks again, is 10 still, now x is 20, so is 20 less than width? Yep, run it. 30x, and it just keeps on going. So now when I run it, I will see a series of lines going across the screen with only a few lines of code. So that allows me to manage this much easier. Just to clean things up so we can see how much more efficient it is, I was very easily, with the while statement, able to get all these lines to appear across my screen. An additional method that we can use for doing loops is it's called a for loop. Working with a for loop is the same but different. So I made a x2 and a y2, so we just have a different set of parameters to work with. So x2, I'll just start that out as 10 as well, and y2 will be started at 10. So if we start them all at 10, we'll be in good shape. So the for loop requires more punctuation, and it then works a little bit different as we work our way through it. So the way that for loop works is we use the word for, parenthesis, and now the for loop has 3 parameters that go into it. So those 3 parameters that are going to happen will be our counter, and then how many times we want that counter to execute, and then how we want that counter to change each time we go through the loop. So the standard convention is a for loop will start out at 0, and then we will say while then I is less than a certain value, and then I, now if we're going to say plus equals 1, because our counter will go up by 1 each time, the shorthand that is commonly used is plus plus. So I is equal to 0, and then we run this loop while I is less than a certain value. Now if you notice on a while loop, it executed, but we don't know how many times it went, because I didn't do the math to go, okay, let's see, my thing is 800 wide. I started at 10, and I want it to go through, how many times until I hit 800 is that? I don't know. I have to do math. I have to think about that. So if I know that I just want something to run, but I don't know exactly where that endpoint is, I just care about that condition, a while loop is a great way to do it. Disadvantage: if you set up a situation where it cannot end, you create an infinite loop. If you create an infinite loop, your program will crash. So it's important while we are working to avoid causing a situation that would create an infinite loop. For loops, on the other hand, generally are designed to run a fixed number of times, and you know how many times you're going to run it. So I may say 10. So it's going to go 10 times. I wanted my while loop to go 10 times. Then I would have to say, let's see, x started at 10, and then 10 times that'd be 100. So then while x is less than 100, do this. So I'd have to do that math and calculate it versus knowing. So a for loop is really useful when we have a fixed number of times and we know that ahead of time. A while loop is we're checking for a condition, but we don't know necessarily how many times it needs to run to execute. So that's the difference between them. In nearly every instance, it is possible to write a while loop where you would write a for loop, and to write a for loop where you would write a while loop. You just have to go about things different. Different programmers will have preferences for one loop style over another. There are some preferences out there where people say the only loop you should ever use is a while loop. And there are some programmers who prefer a for loop for all instances. I tend to be in the for loop category for the kinds of things that I code. The for loop usually works better for me. So I like using that. But most of the time, you can use them interchangeably. You just have to figure out how to write it to work correctly for that. So now with this particular one, I'm going to draw a line at x2, y2, And then this will be x plus, what are we at? 780 plus y2. So for this one, I will create a series of horizontal lines. Now if we run this, I'll see that it drew exactly one line. I want to shorten that. Oh. So each one of my lines, and I needed to change it to x2, not x, so then it now creates the box that I'm looking for. It's drawing the lines out the same spot. So what we need to do is to iterate this or boost it up. So now I could say y2 plus equals 10. And now if we run it, we'll see that it starts to create a graph structure. So it creates those lines as it runs. So two types of loops that we're able to create.